Hey y'all. Sorry, I have to get my chair. Okay, so we are going over independent and dependent events. Here's some vocabulary. Independent events have no effect on one another. The probability of one does not affect the probability of the other. But dependent events means that the outcome of the first event has an effect on the outcome of the second event. So suppose a die is rolled and then a coin is tossed. Those are independent events. So to find the sample space, you would have to pair them all up. So you would have a 1 with heads and a 1 with tails, and a 2 with heads and a 2 with tails, a 3 with heads and a 3 with tails, and so forth. Or you could multiply. There are 2 outcomes for the coin, and there are 6 outcomes for the die, so there would be 12 outcomes altogether. So we're going to deal with independent and dependent events. Alright, so the first thing is determine if the events are independent or dependent. So if you're going to select a marble and select a jack from a deck of cards, the marbles and the jacks don't have any effect on each other, so these would be independent. Hang on, I gotta shut the door. Okay, number 2. Rolling a 4 on a die and then rolling another 4. So if you roll a die and you get a 4, that doesn't have any effect on the next roll. They're totally independent of each other, so this would be independent. Choosing a king, then choosing a queen without replacement. When it says without replacement, that means you do not put that card back, the first card. So if you take a card out of a deck and you do not put it back, that affects the second outcome because you don't have 52 cards anymore. So this would be dependent. Winning a hockey game and scoring a goal. So I know this is something different, but in order to win a hockey game, you must score a goal. If you don't score any goals, you're either going to lose or tie. So these are dependent events because you have one affects the other. All right. Probability of independent events. To find the probability of independent, you might see the word and, or you're going to see the intersection sign, and what you do is you multiply the probability of A times the probability of B. Hi? Yes? Well, what do you need? Okay, go ahead, find it. It's over there. I'm going to keep recording. So if you're going to roll a die has 6 choices, and you're going to flip a coin. There are two chances. What is the probability that you would roll a 3? So that just means a 3 with heads or a 3 with tails. So you would have 2 out of 12, which is 1/6, to get a 3. So 2 out of 12 means you'd have a 3 with heads or a 3 with tails. The probability of a tail. So if you are putting these two together, remember there were 12 outcomes, tails would be half of those outcomes, 6 out of 12. The probability of a 3 and tails. The probability of a 3 and tails, that means you would multiply the probability of a 3, which is 1/6, times the probability of tails, which is 1/2. And so your probability of a 3 and a tails is 1/12, 1 out of the 12 possible outcomes. The probability of an even would be half, because half of them are even. The probability of a heads would be half, because half of the outcomes are going to have a head value. And then the probability of an even and a head, so this is even, and a head is going to be 1/2 for even, 1/2 for heads, which is 1/4. Y'all are looking at the wrong stack. In core 2's tray. That wasn't in the tray, was it? Right. In the tray.
Mr. Buck or Mr. Klein, yeah. Please report to room 212. Mr. Buck or Mr. Klein, please report.
Probability of an even number complement. The probability of an even complement. So if it's not even, the set that's not even is odd. So that would be 1/2. And then the probability of a tails and an even. So the probability of getting a tails is 1/2. The probabilities of getting an even is 1/2. So if you multiply those together, you would get 1/4. To find the probability of independent events, you would multiply the probability of A times the probability of B. Okay, probability of dependent events. How does the first event affect the second event? That is the question. You have to take into account that second event is going to change. So if you have a deck of cards, there's 52 cards, 4 suits. There's hearts, diamonds, spades, kind of look like this, and then clubs. And we're going to do without replacement. That means we're going to take it out, we're not going to put it back. So what's the probability of getting a 7 and then another 7? The first 7 is 4 out of 52 because there are 4 7s out of 52. Now, the next probability of a 7, because our first chance is going to affect the second one, we're not going to have 52 cards anymore, we're going to have 51. And then assuming you pulled a 7, you wouldn't have 4 7s anymore, you would only have 3. So you would have to multiply 4 out of 52 times 3 out of 51. And so that would give you, whoops, I did that wrong. 4 divided by 52 times 3 divided by 51, and that is 0.0045, which is 0.45%. So you move the decimal over twice. The probability of a heart, then the probability of a diamond. So there are going to be 13 hearts, or 1/4 of the deck is hearts. And then if you take one card out, remember we don't have 52 anymore, we have 51. But because I'm doing a different suit, my number would still be 13 because I'm only taking out a heart. So then I would multiply those together. 1/4 times 13 out of 51, and I get 0.0637. Move it over twice, so it's 6.4%. 6.4%. The probability of getting 2 black. So half the deck for the first pick is black. Then, remember, we're only going to have 51 now. And instead of having half, which would be 26, so there's 13 here and 13 here, these are black. I'm going to only have 25 black now, because remember you took one of the black cards out, and I would multiply 1/2 times 25 divided by 51, which is 0.245, and that's going to be 24.5%. So we have almost 25% chance of picking 2 black. All right, the probability of getting a king and then a jack. There are 4 kings out of 52, and then remember we're going to have 51, and there are 4 jacks out of 51. So you're going to multiply 4 out of 52 times 4 out of 51, and we get 0.0060, so 0.6%. So that's how you find the probability of dependent events. And the key is you have to remember to switch that second outcome. So I'm going to give you some to practice. I'm going to do this one with you, and then on the back you're going to do them by yourself. So you have a box with 5 red, 5 purple with replacement. That means when you pull one out, you put it back in. And the probability for red, just a red, is going to be 5 out of 10, which is 1/2. The probability of a red and then purple. So half are red, and then half are purple. Because remember, this is with replacement, so these are independent events, which is 1/4. All right, so the probability of a red and then a purple and then a purple. So half chance of red, we have a half chance of purple, and then we have another half chance of purple. So we have 1/8 of a chance to do red, purple, purple. And if you want to do them percentages, that's fine. We have 50%, 25%, and 12.5%. Now, the same situation, 5 red, 5 purple, except without replacement. So these are dependent events. Dependent events. The probability of choosing a purple is 1/2. the probability of getting a red and then a purple. So there are half of them are red, but instead of 10, I only have 9, and then I still have 5 purple. So you would do a half times 5/9, which is going to be 27.7 repeating, so 27.8%. Probability of a purple, purple, red. So again, we have half are purple, and let's say we take a purple out. Then that means we're left with 9, and I want another purple, but I don't have 5 anymore. I only have 4 because you took one out. Then I'm left with 8 marbles because I've taken 1, 2 out. And now I want red, but I have 5 red left. I've only taken out 2 purples. So I'm going to multiply all these fractions together. A half times 4/9 times 5/8. And that gives me 0.138 repeating, so 13.9%. And then the last one says the probability of pulling 5 red marbles in a row. So this would be 5/10 times 4/9 times 3/8 times 2/7, 1, 2, 3, 4, and then 1/6. And to figure that out, 5 red in a row, you would multiply all of those out, and then you would, so that's half, it's going to be, let me type this in, so half times 4/9 times 3/8 times 2/7 and times 1/6. And it is 0.49, 3/8, 2/7, 1/6. It's 0.00396, which would be 0.396%. So a less than 1% chance to do 5 marbles in a row. All right, so these last 2 are you tries. I want you to work them out, and we will go over them in class tomorrow.